Alright, here we have another example that says find the center HK and the radius R of each circle. Then graph the circle and find the intercepts if there are any. Okay, so our example problem looks like this. And again, since it is more in general form, we need to get it into standard form so that we can read the center and the radius and all of that, those stuff that we need out of there. So I'm going to go about completing the square. If you'll remember that completing the square is how we go about transforming it into standard form. So we're going to put our x's together and then leave a blank, and then we have to put our y's. Oh, there is no other plain y term, right? That's going to be interesting. We do have a constant term that needs to be moved over to the other side, so that would make that a -7. Alright, looking at our x's here, we'll deal with x's independently of y's. You can only complete the square if the coefficient in front of the x squared is a 1. In this case, we have a 2 in front of that x squared. So we actually literally have to factor that out the front. So if I factor the 2 out, I now have x squared plus 4x and then a blank, and then I'm going to close my parentheses because I'm just factoring it out of the x's. Plus, here there is nothing to complete the square for our y values. In order to be able to complete the square, you have to be given a y squared or an x squared or whatever, and a x to the first or y to the first, whatever variable you're working with. So since we don't have a y squared and a y, there is no trinomial to complete. So we would just say plus 2y squared equals -7. Now we can go through and we can complete the square on this trinomial in our parentheses here. And we do it the exact same way we did before. We would take 1/2 of 4, which would be 2, and then square it, which would be a 4. So we would add 4 in on the left-hand side. But now if you think about it, we didn't just add 4 over here, because remember we have this 2 on the outside that has to be able to be distributed, and you get right back to where you started. So 2 times 4 is 8, meaning what we actually introduced on this side is not a 7, but it's actually an 8. So we're going to have to balance that out by putting plus 8 on the other side. Alright, now let's see what that did. So 2 times, now this is a perfect square trinomial, so it will factor into x plus 2. Remember, it's always the x, or the variable, and then that half value amount. Okay, plus 2y squared equals -7 plus 8 would be a +1. Now we're still not completely done. This is actually like one that we've worked before, where we did not have 2's in front of our x minus h's and our y minus k's and all of that. So in order to get rid of it, we're going to have to divide everything by 2 so that the 2's are gone. So now we have x plus 2 quantity squared over 2. I'm sorry, not over 2. We canceled that 2, didn't we? Almost caught me there. Plus y squared equals 1/2. This is our standard form. Now from that we can read our center, which would be x minus a -2, and then there's nothing being subtracted from the y, so that would be a 0. Our radius would have to be the square root of 1/2. Now if you don't believe me, remember that that 1/2 is in the squared position. So if we take the square root of both sides, we get r equals, the square root of 1 is 1, over the square root of 2. And we would have to rationalize the denominator in order to get the square root of 2 over 2.